Hustler here. I'm going to give you notes on how we can apply that first and second derivative test, okay? So we just went through the key ideas, the golden rules that are going to help us answer these questions, and so now we're going to go ahead and apply that. So the graph of f prime of x is given below. Use it to answer questions about f of x, given that f is differentiable for all x, and f prime of x, as you can see, is continuous and differentiable for all x, meaning I can take the derivative of both f and f prime. So it says make a sign chart for f prime. And again, I have the graph here of f prime. And when I go to make my sign chart for f prime, the first thing I'm going to do is label it. Remember, I'm looking for when f prime of x is equal to 0. And so f prime of x is equal to 0 at -3, x equals 0, and x equals 2. Okay? And then when I make my sign chart for f prime, I'm looking at the outputs of f prime. And so the outputs of f prime to the left of -3 have negative outputs. To the right of -3, or between -3 and 0, has positive outputs. Between 0 and x equals 2, f prime of x has negative outputs and then positive outputs, okay? And that will give me information about f. But now I want to do something a little different. I want to make a sign chart for f double prime of x. And again, I like to label. And what I'm looking for is, sticking to this theme of where f double prime of x is equal to 0. And we just reviewed, and yesterday we talked about the fact that f double prime of x is equal to 0, where f prime of x has a horizontal tangent line. So if I were to draw in a horizontal tangent line for f prime, there would be two spots where that would occur. And I'm just going to estimate those spots to be at x is -2 and x is 1. Okay, so again, we're looking for f double prime of x to be 0. F double prime of x is the slope of the tangent line to f prime, or the derivative of f prime. And f double prime of x is equal to 0. In other words, f prime of x has a tangent line that is horizontal when x is -2 and 1. And so to fill out the sign chart for this second derivative, this f prime, again, I'm looking at f double prime. F double prime are the slopes of tangent lines to f prime, okay? And as I start on my journey along this section here, if I were to draw on tangent lines, I would have positive slopes for those tangent lines. And then as I continue on my journey, if I were to draw in tangent lines, I would have negative slopes between -2 and 1. And then again, as I continue on my journey, if I were to draw tangent lines to f prime, those slopes would be positive slopes to the right of 1. And so that would be how I create my sign chart for f double prime. Okay, so again, I was looking where f double prime of x was 0, and then I was looking at the slopes of the tangent lines to f prime to help create the sign chart for f double prime. Okay, so now I gotta go and answer some questions. On what intervals is f increasing, and justify? And just a reminder, we said that f is increasing when f prime of x is positive. Okay, now I don't have the graph of f, but I do have f prime. And in fact, at this point, I no longer really pay attention to my graph because my sign charts are going to give me the information that I need, okay? And my answer should be in intervals of x. So this is just a review. The directions do say on what intervals, but given in intervals of x, okay? All right. So f prime of x is greater than 0, if I look at my sign chart, from -3 to 0 for x, and for all x values bigger than 2. And so I'm going to answer the question. It says to justify, I need to give an answer. I like to restate the prompt. F of x is increasing on the intervals -3 to 0, so less than x less than 0, and x greater than 2 because f prime of x is positive. Okay, so I need the what, that's the increasing, the where, that's the intervals, and the why, because f prime of x is positive. Okay? Okay. It says list all of the values of x where a relative minimum of the graph of f of x occurs. Justify. Well, again, I don't have the graph of f. I have the graph of f prime, but I know a relative min for f occurs when f prime changes from negative to positive. So by me writing this little note to myself ahead of time, I'm really coming up with a justification. All right, so again, I'm not going to pay attention to my graph anymore. I feel like this sign chart's going to give me everything I need. I'm looking at when f prime changes from negative to positive, and that's going to occur at an x value of -3 and an x value of 2. So I have two answers here, okay? I'm going to state the what. So f of x has a relative minimum at x equals -3 and x equals 2 because, and I'm keeping it real simple here, people. Okay, it's because f prime of x changes from negative to positive. Okay. Okay. Let's see. E says list all of the values of f where a point of inflection for the graph of f occurs. Okay, so this was the new idea that we talked about. And when we talked about the point of inflection, we said the point of inflection is either where f prime has a min or max value, or where f double prime equals 0 and changes signs. So it's totally up to you which way you want to approach this. If I look at my graph, I can see that f prime of x has relative extrema at -2 and 1. If I look at my sign charts, I can see that f double prime of x is equal to 0 and changes signs at -2 and 1. And so I'm actually going to give both answers for you so that you can see both justifications, both proper justifications, okay? And I can say this. I can say f of x has a point of inflection. And please spell it out because College Board may not take POI as an answer. All right, at x equals -2 and x equals 1 because, okay, so I stated the what, it's a point of inflection, the where, x equals -2 and x equals 1, and now I'm about to state the why. And you can do one of two reasons. You can either say, because f double prime of x equals 0 and changes signs. If f double prime of x does not change signs, that means that your f graph went from, let's say, concave up to still concave up. There would be no point of inflection. So your second derivative has to change signs in order to be changing concavities to have that point of inflection, okay? Or you could say that f of x has a point of inflection at x equals -2 and x equals 1 because f prime of x changes from increasing to decreasing right? That is how you get that relative max for f prime, and decreasing to increasing, and that's how you get that relative min at f prime. Okay, so either of those two options would be valid conclusions. All right, it says, on what intervals is the graph of f of x concave down? Okay, well, for f of x to be concave down, we're looking for when our second derivative of f is negative. This is going to require me to take a look at the sign chart for f double prime. It looks to me like f double prime of x is negative on the x values from -2 to 1. You could also say that f of x is concave down when f prime of x is decreasing. And if I go back to my graph here, f prime of x is decreasing between -2 and 1. So you have some options here in answering this question. I'm going to answer using both of those solutions, so you can pick which route you want to go. Again, I'm going to restate f of x is concave down. Do not abbreviate. AP College Board may not know what you mean by CCD, okay? On the interval, -2 less than x less than 1, or you could write -2 to 1, doesn't matter which notation you use, because you could either say because the second derivative, f double prime of x, is negative, less than 0, or you could say that it's because f prime of x is decreasing, and I can clearly see that in the graph. So either of those explanations would be appropriate explanations. Okay, I'm going to go ahead and flip over and record a video for the second question. All right, I'm back for problem 2. It says, given that f of x equals -x cubed plus 9x squared minus 24x, complete each of the following. So first I ask that you make a sign chart for f prime of x and f double prime of x. And I will tell you that the AP questions do not require you to do this. However, I have found that this strategy has been very helpful in answering the questions that follow. And so I just want to form a good habit of making these sign charts so that I have the information up front. All right, in order to make the sign charts, I first have to determine when f prime of x is equal to 0 and when f double prime of x is equal to 0. And in order to do that, I need to find f prime of x and f double prime of x. So as a reminder, to take the derivative of f, I'm going to get -3x squared plus 18x minus 24. I want to find the critical values so I can make a sign chart. So I'm going to set this equal to 0. I can factor a -3 out. That gives me x squared minus 6x and then plus 8. That can be factored further into x minus 4, x minus 2. And so if I were to set each of these factors equal to 0, I would get that x equals 4 and x equals 2. And then I can use that information to make a sign chart for f prime, and you want to make sure that you put those in numerical order since, my apologies, since this is a number line. There we go. I had -2 on accident. Okay. And then again, to fill out this sign chart, you're going to evaluate f prime of x for values within each interval. So I might pick an x value of 0 because that's the easiest to do. And if I substitute 0 into this f prime function, I'm going to get a negative output. And then maybe I would substitute 3 in. And I actually think it's easier to substitute into the factored form. I would have a negative. 3 minus 4 is another negative. That multiplies to be a positive. 3 minus 2 is a positive. Positive times a positive is positive. Okay. And then I'm going to evaluate at 5. Again, I'm going to put it into this factored form. So that would be a negative times 5 minus 4, that's a positive. 5 minus 2, that's a positive. Negative times positive is a negative output. Okay. Okay, so now I need to find the second derivative so that I can make a sign chart. There we go. And so to find the second derivative of f, I'm going to take the derivative of f prime. So I'm going to take the derivative of this function right here. Oops, why do I keep doing the highlighter? Sorry. Okay, there we go. So f double prime of x. When I take that derivative, I'm going to get a negative 6x and then a plus 18. To make this sign chart, I've got to find when f double prime of x is equal to 0. So I get 0 equals negative 6x plus 18. If I subtract 18 from both sides and divide by negative 6, I get that x is 3. Again, I'm going to label my sign chart. 3 is the critical value that I put onto this sign chart, and I'm going to evaluate for values to the left of 3 and to the right of 3. I always like to pick 0 if I can. And again, I'm going to put them into the second derivative since I'm looking at outputs of f double prime. And if I substitute 0 in for x, I'm going to get a positive answer. And then I'll pick 4. If I substitute 4 in for x, I get a negative 24 plus 18 gives me a negative output. So now I'm all set to start answering these questions. And again, I'm going to go back to that summary page and use that summary page to help me with my justifications. On which intervals is f of x decreasing? Well, f of x is decreasing when f prime of x is negative, okay? When f prime of x is negative. And because I have my sign charts, I can look to see that f prime of x is negative to the left of 2 and to the right of 4. So I'm going to say f of x is decreasing on the interval, I'm just going to say negative infinity to 2 union 4 to infinity because, or you can use the inequality notation, and it's because f prime of x is negative or less than 0, okay? So by me saying this ahead of time, it helps me give that justification. C says, identify and classify all extreme values of f as a max, min, or neither, and justify your answer. Well, in order to be a max, f prime has to change from positive to negative. To be a minimum, f prime has to change from negative to positive. To be neither, f prime does not change signs at that critical value. When I look back here at my sign chart for f prime, I see that I do change signs at each of those critical values. So I'm just going to start with the first one. I'm going to say f of x has a relative minimum at x equals 2 because f prime of x changes from negative to positive. Now, some of you might want to say because the slopes of the tangent lines to f change from negative to positive, but you don't want to say because the slopes of f prime, that would be the second derivative, and that would not be true. So that's why I keep it simple, because f prime changes from negative to positive, and f prime are the slopes of the tangent lines to f, okay? I have to identify the other one, so f of x has a relative maximum at x equals 4 because, again, keeping it simple, f prime of x changes from positive to negative. The slopes of my tangent lines to f change from positive slopes to negative slopes. I can simply just call that f prime. Okay, let's take a look at D. D says, I'm going to move it so I can still see my sign charts. D says, at what value of x does f of x have a point of inflection? Okay. Well, I don't have a graph here, so I can't make any comments about f prime increasing or decreasing. And so I just have to simply go with the fact that f double prime is changing signs. So if I don't have a graph, again, I can't make any determinations about f prime and what that is doing. But I can, based off my sign chart for f double prime, state that f has a point of inflection, spell it out, at x equals 3 because f double prime of x changes signs. I don't have to put that f double prime of x equals 0. If f double prime of x is changing signs at x equals 3, it's understood that in order to change signs, you have to pass through 0. So you can just simply state that f double prime of x is changing signs, and that is why I know that f has a point of inflection. E says, on what intervals is f of x concave up? Well, f of x is concave up when the second derivative of f is positive. And again, looking at my sign chart, which is up in that corner, I can see that f double prime of x is positive to the left of 3. So I'm going to go ahead and restate f of x, spell it out, is concave up on the interval negative infinity to 3, or you can say x less than 3, because f double prime of x is positive, or you can say is greater than 0. All right, and finally, the last question says, on what interval or intervals is f of x concave down? Well, f of x is concave down, again, when the second derivative is negative. I know that we also said that we are concave down if f prime is decreasing, but again, I don't have a graph here to make that determination. And so if I don't have a graph, I can't make the statement of f prime decreasing. I can't see that f prime is decreasing. So I have to base my answer off the second derivative. So I'm going to say, looking at my sign chart, f double prime of x is negative for all x values greater than 3. Okay, so I'm going to say f of x, spell it out, is concave down on the interval 3 to infinity, or you can say x greater than 3, because f double prime of x is less than 0 or negative. Okay, so keep your answers simple and to the point. Use that golden summary that we talked about in terms of f connected to f prime connected to f double prime. And make sure that you have these problems with you for tomorrow when we work through the practice.